Hello, this is Amro Lewis, Team 47 with Arthur, Michael, and Michael. This is our last video for our project in haptic fashion. Our goal was to build a wearable proximity sensor, and we were able to achieve our goal by installing a sensor and a vibration motor on a pair of glasses.
Hi, I'm Michael Sell with Team 47. According to the CDC, there are approximately 12 million people in the United States who are over 40 and have a vision impairment. The idea behind this project was to help guide the visually impaired using a haptic feedback control. Overall, we are happy with our design. We achieved our fundamental goal of detecting obstacles. Our design is compact and has a lot of potentials. There were a lot of challenges throughout this project. We had to change our designs multiple times. Initially, our design was haptic shoes, then we changed to gloves, and then finally glasses. We also changed our sensor from first at ultrasonic to a lighter sensor, and the range of the sensor was much less than we expected at first, and we were able to fix that in the code. All of these challenges and changes were to improve our design.
I'm Michael Cartmel, Team 47. I'd like to discuss a couple issues that we ran into for this project. We ran into an issue with an extremely high failure rate of the vibrator motors right out of the package. Upon further investigation into this, it seems that this was reported for these by other people who had purchased them. Some others, however, had no issues with the same ones. This began to point to an issue with the quality control from the manufacturing company. Sometimes this made for a difficult time troubleshooting. Something else we found is that when we would run both the LiDAR and the Bluetooth module constantly, there was an issue with them not working properly. Upon further research into this issue, we found that it was not unique to us, and others had reported similar issues with multiple high-speed modules, like the LiDAR and Bluetooth module. Most of the research had come to a conclusion that there was some sort of clocking issue between each module and the microcontroller chip. To get around this, we set up the code to only go into a mode that used one or the other by looking at a jumper on the PCB. If the jumper was on, then it would use the Bluetooth in order to set parameters. Otherwise, it would just use the incoming LiDAR data. We would need to continue to investigate this, as having the ability to use both at the same time would open up some additional options for increased features.
Hello, I'm Arthur Kim of Team 47 and I'll be going over the final design of our project. The whole design was decided to be on a pair of glasses, and these in particular were 3D printed in order to house all the components. You can see it's along the side and on the front. We have here our PCB, and it's designed off the Arduino Uno and uses the same chip as the Arduino Unos, and that chip is right here, you see. And we have two motors that provide the haptic feedback through their pulsing vibrations, and they are right here and right there. Our sensor is a LiDAR sensor that is mounted at the top here because it would be the best placement for a sensor such as this to be placed on the head. So this is our sensor right here. Finally, we have a Bluetooth module on the side, and it's mainly used to troubleshoot and set the threshold distances to whatever we desire. Finally, the whole design is then powered through these leads right here, and these leads would then be connected to a 9-volt battery, and that would power the whole system.